when we're working with shifting ellipses, really the only thing that changes is you have an H and a K. That's it. The H still goes with the X, the K still goes with the Y. Your values of A, B, and C don't change. A is still going to be the value of from the distance from the center to the vertex. The B value is still going to be the distance from the center to the co-vertex. The C value is still going to be the distance from the center to the focus. All of that is the same. It doesn't change whatsoever. What changes is where the center is. That's it. Okay. So let me show you the generic form of the equation. I just put it all in one. The only thing, the same thing deal goes. A squared is always the larger of the two values. So if your A squared is underneath the X squared term, which direction is it being pulled? Horizontally. And the other one will be vertically. So the only thing we're adding to this, guys, is the H and the K. Yesterday you had an H and a K, they just happen to both be 0. That's all. I do know that some of you guys have that app on your calculator with the generic form of the equation. They were asking about it in Flex again about, will you have to memorize that? No. And because you have that there. And I've been known to make sure that you guys can't use calculators a lot of times because I'm a bit of a jerk. But what I have done is that I've taken these app pictures and I've taken this image and just the image for all four of the conics that we'll look at, and I put them on a cheat sheet of paper. So if you guys do have to use a test or a quiz, if you don't want to go back and forth with the app button, I'll have that on a sheet of paper. I know not all of the calculators have the app. I don't know, did you have yours on there already? I mean, you can download it right from TI's website, but you do. Otherwise, because we were having problems with Kobe with his, I couldn't get it to transfer it correctly. So if you don't have the app, I've got a transfer cable. We could send them back and forth. If not, it's not that big a deal. Sir. You were going to ask something. Oh, good conversation. Yeah, I like that. Also, when we get to finals, yes, I know you will have to take a finalist class. Yes, it's hard. I'm not going to lie to you.
What?
Finals are hard. Of course they're.
Seb's finals were easy.
Well,
Seb's finals were easy. So how is
I'm just making stuff up. I haven't even written the final yet. Anyway, what happens here is that there will be formula sheet for certain things. The conic formulas would be something I would give to you on a formula sheet so you can have, okay? There are some things that you get to have. So let's go back into this then. It's the same scenario as it was yesterday. We're still going to do the same process to go through it. We're still going to identify A, B, and C. We're still going to walk things out. We're going to label vertex, co-vertex, focus, and things like that. To be honest with you, this should be pretty easy. So, let me show you an example. Do you have this yet? We good? Let's start with this. Let's graph this and identify everything. You got a question?
For ellipses and stuff, H and K, is it still like the two vertexes? Or is
It's
it
the center.
But for parabola, is it the vertex? Okay.
I know it's a little weird how it does it that way. So we have the quantity x minus 3 squared over 25 plus the quantity y plus 6 squared over 49 is 1. Right. Which way is this going?
It's going up and down.
It's going up and down. Why is it going up and down?
Because 49 is a bigger number. So.
49 is a squared.
Or yeah, squared.
Yeah. But you're on the right track. You guys got all excited, and I'll give you that. So just like yesterday, we noticed that it's going to go vertical. So we just draw the little diagram on there so we know what to do. Where is my center going to be located at?
3,
3 negative 6, very good. So there's my center. Now I know that my a squared is 49. My b squared is 25. So what's a?
7.
7.
Or
Negative 6.
Yeah, that.
b is,
Plus or minus 5.
then our c squared, remember it's the same way we did yesterday. It'll be 49 minus the 25, a squared minus the b squared. Yes, ma'am?
I totally just remembered I had a question on the homework, but like for one of the problems I wrote like root something, but it could be simplified. Is that okay?
I want you to simplify roots. You can do it in the calculator. Okay. What's the square root of 24?
2 roots.
So your c value is plus or minus 2 root 6. I now have everything that I need to do to plot.
Gosh, this is so easy.
Okay. So we start.
You can't see.
Oh.
Oh, man, this is easy stuff. It's just
Right now, you guys are really starting to get worried right away, aren't you?
Are you not used to it?
I've taught this class for a few years. You guys always, yeah, you're like Cubs fans. You're pessimists. Welcome to my world. 3 negative 6.
Dang. I got
There's my center. 3 negative 6. Like the guy said, stretch vertically. So when I walk my a value, I just have to walk up 7 and walk down 7. So that means that it's the a values are all going to be on the same vertical line, aren't they? Which means what coordinate doesn't change? The x. The x isn't going to change. Yes, sir. I'm going to add to it. We're going to add the shift to it. Yeah. So what is negative 6 plus 7? So one of my vertices is at 3 and 1. The other one would be at 3 and, well, negative 6 minus 7 is?
13.
Negative 13. Notice how I'm just adding and subtracting to whether the... That's exactly what I'm doing.
You told me to cut the two. That's for like, oh.
To go to the co-vertices, I don't have to change the y values, now I change the x values. I change them by how much?
6.
5.
5. So I add 5 to it. So it is now at 8 negative 6 for the co-vertex. Subtract 5. And I'm at negative 2, negative 6. And what's the last thing I have to put in there? Focus. Yes, ma'am.
Isn't 7 from 3 negative 6 2? Like 3 2?
What's negative 6 plus 7? Now, when I do the focus stuff, the focus is still going to be the value of c, which is the distance from the center to the focus. Now, that means I have to add, we know it's going to go vertically. It has to go up and down 2 root 6. Well, 2 root 6 is the square root of 24. The square root of 24 is just a smidge left of the square root of 25, isn't it?
Yeah.
So I basically walk up almost 5.
Yes.
Okay, so count up almost 5. So from negative 6 up almost 5 would be almost negative 1. And almost down here. But what do I do about labeling those as far as what the exact values are? Well, all you do is, your focus then are going to be at 3 comma, because it's still going to be the same x coordinate, negative 6 plus 2 root 6, 3 comma, negative 6 minus 2 root 6. And that tells me exactly where they are. If I just put it in the plus minus versions of the roots. I really don't care what the decimal is. I kind of placed it close-ish to where they would be, around 5. But then I labeled it specifically. Does that make sense?
Of course.
When you're working with the radical, especially with the focus, you see more radicals with the focus than you do some of the other ones. That's all you have to do is just add them in like that. And then you're going to do a rough approximation on the graph. Not very scary, is it? It looks like it's going to be awful.
Are we gonna draw an ellipse where it's not straight up and down or side to side like it's got an
No.
angle? Will we ever know?
That's called something different, and I think you do it in pre-cal. I don't remember what that's called.
It's not complicated.
It's a conic, but I forgot what it's called.
It's called torsions. What if you did those non-ellipse, it's not a circle?
Or correct?
Or around.
Then it might be a hyperbola.
Like, no, you don't.
Not a conic then. Oh. I mean, it's not a tuba. All right, let's do this. Focus at 3, 5, 3, negative 1. Vertex at 3, 6, 3, negative 2. Let's write the equations given that information. We did this yesterday as well. But one of your ordered pairs was always 0. Today it's not. But you can still figure out which direction everything's going and still walk to figure out your values of A, your values of B, maybe your values of C, and still be able to substitute in. So if my foci are at 3, 5, 3, negative 1, my vertices are at 3, 6, 3, negative 2, what do you think I should do first to figure out what direction this is going? Draw it. Plot it first. Plot it first. So if my focus is at 3, 5, and my other one is at 3, negative 1, what direction does this have to go? Up and down. So what's the A squared going to be underneath? Y. Very good. So write it out. You know it's got to go like this. So you know it's got to look like that. So plot the other value in. The other one is the vertices. The vertices are at 3, 6 and 3, negative 2. I know for dead certain where one of the coordinates for my center. Which one do I know? Which is?
3.
3. Good. I know my center is going to be at 3, comma. Sum. The center is the midpoint of either the focus or the vertex, or heck, even the co-vertex. The center is always going to be equidistant between those. So what is 5 plus negative 1? 4. What's half of that? 2. So my center will be at 3, 2. So I now know my H and K. Now the fun part, counting. I know that the value of A is the distance from the center to vertex. So, going from 2 to 6 is A. How much is that? 4. So A is 4. From center to focus is C. How much is that? 3. So then C squared equals A squared minus B squared. Well, if A is 4, A squared would be 16. If C is 3, C squared is 9. So 9 is 16 minus what?
7.
7. So what's your b squared? 7. Okay. I don't have to do square roots. I don't have to do any of that. I now know my center, which is my h and k, and I know my a squared and b squared. I substitute it and I'm done. X minus 3 quantity squared over 7 plus y minus 2 quantity squared over 16 is 1.
Yeah.
Okay? Yes, ma'am.
For the center, we just counted it, right?
Yeah. Yeah, you're just doing the midpoint. The center is always going to be the midpoint of your co-vertex, your vertex, and your focus. All three of them. It's always going to be the midpoint. It's a nice, easy way to remember it. Okay? It's really not frightening, is it?
That's the cheesiest cheese I've ever seen in my life.
That's what I'm here for. All right. Well, then let's do this one. Yay. Let's just make it all. Just rip the Band-Aid right off and just go to town and have fun. All right.
Hey, this is a completely square one.
It is. It's a lot of complete the square.
Jesus.
So what we're going to do here, we're going to complete the square twice to go ahead and put it into the general form of the conic, which is we're going to figure out what it is by doing all that work. So we have 9x squared plus 4y squared plus 36x minus 24x.
You mean y?
24y plus 36 is 0. Yeah, don't take stuff out yet. There's a nice little trick that I wanted to show you guys here. Before you do anything, move your constant and group together your x's and your y's. Right? Take an extra step to do this. So we get 9x squared, 36x, 4y squared minus 24y equals negative 36. All I'm doing there is spending a little bit of extra time to move things around just to prepare it for completing the square. Because when I complete the square, my first term has to be what? 1. Yes, it has to be x squared. I'll give you that. So my leading term coefficient has to be 1. That should have rephrased. So here, I have to take out the 9 right away. And I get 9 times x squared plus 4x plus blank. Take out the 4, y squared minus 6y plus blank equals negative 36 plus blank plus blank. But here's the problem. I factored out a 9 here. I gotta put the 9 here
And the 4.
and the 4. Just reminding you of that. Since we took out the 9 there, and we're not setting sides equal to 0 with that singular term like we did back then, it was a little bit of a shortcut. I have to make sure to throw that 9 back in, okay? Because when I complete the square, it really is 9 times this quantity. So when I do that, it'd be 9 times, in this case, it'd be 4. I'll put it back over there. So here we just go through the process. Half of 4 is 2. 2 drops to my parentheses just like it did before. When I square 2, I get
4.
So bring the 4 to both sides. Bring the 4 down for the parentheses. Half of negative 6,
Is negative 3.
negative 3. So it becomes, oops. Square it, and I'm adding 9 to both sides. Now I get negative 36 plus 36 plus 36. 36.
To be honest, I kind of like the big
Wait, didn't we have something like this when we were in?
Oh yeah, we've done
I
something.
kind of do. Because it's like, it's simple.
I
It's a
like
bunch of small
math.
steps. I hate math.
I do my math homework for
This
fun.
class made me hate it.
One of the things that this book tends to do with the completing the square, especially with the conics, is you're going to see a lot of 9s, 4s, 36s, 64s, 72s, 25s.
49.
You'll see 49. You'll see a lot of stuff with perfect squares because they're trying not to overburden you with really difficult A, B's, and C's. You'll notice that a lot of your A, B's, and C's, usually 2 out of the 3 of them, are pseudo-decent numbers to work with. There's usually only 1 of the 3 that's kind of a pain in the butt. Not to say it doesn't happen more often, but this book does tend to try to make it a little bit easier. You never know. I've been known to give fractional ones here and there, and we'll get there. You got time, no worries. So what do I have to do to get that side equal 1?
Math.
Divide by 36.
Divide by 36. Subtract 35. Get out of my classroom. There's always one, and that's why I always said, I start preempting that comment by saying, besides subtracting 35.
It's a circle.
How do you know? If it was a circle, the A and B value would be the same. Here it doesn't, you don't get the same value for A and B because what's 9 over 36? It's x plus 2 quantity squared over 4. And the other one would be y minus 3 quantity squared over 9.
I was thinking of something.
And that's one thing. And this is how you're able to distinguish between an ellipse versus a circle. A circle will have A and B values that are the same. Because if you think about it, in a circle, if you're going from the center to your vertex, wouldn't that also have to be the same distance from your center to your co-vertex?
So a circle's an ellipse.
So this is an ellipse that has to be stretched what direction? Up and down. It's vertically. Do I need to walk you through how to graph that? Or can you do that on your own and label everything?
Easy peasy, bro.
They keep talking today.
Today?
Especially today.
I don't know. No, actually, believe it or not, we only have 2 sections left to really go through. The hyperbolas and the shifted hyperbola, that's technically, we could probably do it all in one day. But what'll be difficult within that is remembering how to find slant asymptotes. Once you remember how to write the equation of the line, give them 2 points, it's pretty simple. And then we may or may not do the intersection of conics, find systems of equations of conics. I don't know, it depends on time. At the earliest, I would say that we would probably test on conics next Friday.
Let's not and say we did.
There really aren't any good problems with conics. I mean, seriously, there really aren't. What's that?
I was like,
I'm getting there.
Homework?
I don't know. Stop.
Wait, did you say
Go ahead and take a minute, write down the equation for me. Take a minute and go ahead and do this one.
And I can already tell you it's going to
We're going to graph it. We are at 2, -4, 5, -4, for the foci, which means it's going to go left and right. We know it's got to go left and right, which means a squared is underneath the x. Vertices at -1, -4, and -8, or excuse me, +8, -4. Find the center. First thing you're going to do is the midpoint between any of those. So your midpoint is at 3.5, comma, -4. Center. 3.5, -4. Now, to figure out your value of A, your value of A is the distance from the center to the vertex. Well, to go from 3.5 to 8 is how much?
4.5.
4.5. So that means A is 4.5. To go from 3.5, your center to the focus, which was at 5, was how much?
1.5.
Wait, center to the focus
To the focus.
is the what?
One-
That's
Oh,
C.
that's what you drew on the board the other day.
So now,
Yeah, you
so now you find a squared, b squared, and c squared. So c squared, well,
It's
15
one.
squared is 225, so 1.5 squared would be 2 1/4.
I can't see.
4.5 squared, if I'm not mistaken, is 20 1/4.
Yeah.
So a squared is 20 1/4. So if c squared is found by, yes, go on. If c squared is found by taking a squared minus b squared, 20 1/4 minus what is 2 1/4?
81.
So b squared is 18. Do you have enough information to write that out?
Wait,
Which one's larger, 18 or 20 1/4?
20 1/4.
Remember, when my y value for my k here is negative, or if it was for my h value, it's going to be y minus the negative 4, so it's y plus 4. Quantity squared over 18.
yay!
What's the homework?
Something.
Thank you for sharing.
Can we do another one?
No.
Can you go with
I always feel bad that I forget to raise it up higher for people in the back. Both of you guys are kind of like, can't see so good.
If it makes you feel better, he likes to stand in front of where, like I can see. You did the same thing last year,
Hey,
that's why
you
I
picked the
moved
corner.
over here.
You picked the corner.
Whatever.
Are we all right?
No.
I'm getting there. No worries. I just was going to pull the homework out.
Can you just tell us the homework?
I don't know what the numbers are off the top of my head.
Well, I'm ready to write it down.
17, 18, 24, 25, 54, 55, 58.
Oh, sweet. There's only like 6
That is
It's also 7, but counting is something.
This is only math class. Who cares about numbers?
Yeah, this is
My logic,
10.6. What I did here is I picked ellipse problems again, but
Read the problem.
remember, some of them might be in that grouping where it could be an ellipse.
25.
Parabola.
55.
Stop.
Okay. It might even be a circle, you never know. All right?
16.
You missed 16.
You said 17.
17, there is no 16 here. Guys, she's helping me out by doing that. Enough with it.
Sorry.
17, 18, 24, 25, 54, 55, 58.
Thanks, Marco.
You're the best.